Welcome to a video where we will learn how to locate the intercepts and turning points of polynomials using Desmos. Let's get started. The intercepts are where a function crosses the x-axis or the y-axis. A polynomial of degree n will have one vertical or y-intercept and at most n horizontal or x-intercepts. A turning point is where a function changes direction. So it could change from increasing to decreasing or from decreasing to increasing. Turning points are also known as relative maximums or minimums or local maximums or minimums. A polynomial of degree n will have at most n-1 turning points. Let's go over the steps on how to locate the intercepts and turning points using Desmos, and then we'll look at a few examples. We need to enter the function into a cell on the left, and then we'll click on the points of interest to reveal the coordinates. Let's determine the intercepts and turning points for the function f of x is equal to x to the fourth minus 9x squared minus 4x plus 12. Let's go over to Desmos and enter this in. From the Desmos.com website, click on the button in the middle to open the graphing calculator, or from the Math Tools pull-down menu, select the graphing calculator option. Let's enter the function on the upper left-hand side. You can adjust the thickness and color of the function by pressing and holding on the graph settings button on the left. I'm going to change the thickness and I'm going to change the color of this function to black. When we look at the graphing window, we cannot see the complete graph. You can either use your mouse to zoom in and out, or you can use the zoom in and out buttons on the upper right-hand side. You can also set the graph window by clicking on the wrench and then editing the dimensions for the x-axis and the y-axis. For this function, I'm going to use the x dimensions between -5 and 5. And for the y-axis, I'm going to use between -20 and 20. Now let's find the intercepts and turning points for this graph. Click on the graph and you'll notice it highlights some of the points in gray. Click on the point to reveal the coordinates. So this graph has a y-intercept at 0, 12. It looks like this graph has 3 x-intercepts. To reveal the coordinates of each x-intercept, click on the points. So we have an x-intercept at -2, 0, 1, 0, and 3, 0. The turning points are where the graph changes direction. Moving from left to right, our first turning point is where the graph changes from decreasing to increasing. Once again, click on the graph to reveal the turning point. That first turning point is at -2, 0, which also happens to be one of our x-intercepts. The second turning point is where we change from increasing to decreasing. Click on the point to reveal the coordinates. It looks like our second turning point is located at the point -0.225, 12.447. And finally, our third turning point will be at 2.225, -16.947. Let's go ahead and look at our next example where we're going to do the same thing, determine the intercepts and turning points for the function g of x is equal to x cubed minus 2x squared plus 9x plus 18. Let's go back to the Desmos website and enter this function in. I've already entered the function into the left side menu, and I've already adjusted the window settings. This graph has a y-intercept at 0, 18. It has an x-intercept at -1.3370, and there are no turning points on this graph. Now let's take a look at our last example. Let's determine the intercepts for the function h of x is equal to x to the 6th minus 9x plus 12. Let's go back to Desmos. Once again, I've already entered the function into Desmos for us. I've also adjusted the graph settings on my graph. It looks like we have a y-intercept at 0, 12. There are no x-intercepts on this graph. And we have one turning point at the coordinates 1.084, 3.866. Let's summarize what we've learned in this video. Every polynomial of degree n will have one y-intercept. All of the three examples had a y-intercept. That's true for every polynomial because its domain is all real numbers. Every polynomial of degree n will have at most n x-intercepts, but it could have less and it could have none. On this video, we looked at several examples where there were multiple x-intercepts, only one x-intercept, and no x-intercepts. And every polynomial of degree n will have at most n minus 1 turning points. We looked at some polynomials that had multiple turning points, one turning point, and no turning points. I hope you found this video helpful. That's it for this video. Thanks for watching.